Welcome back, students. In the previous video, I have told you about charges, and now in this video, I will tell you about the units of charges and the different particles. So, first, the units. The unit of charge in SI system is coulomb, while there are the two units in CGS system. One is ESU, electrostatic unit of charge, which is also known as stat coulomb, and the other unit is EMU, electromagnetic unit of charge, which is also known as ab coulomb. Here, the relation between these stat coulomb and the coulomb is like this: 1 stat coulomb equals to 3.336 into 10 to the power of minus 10 coulomb, and 1 ab coulomb equals to 10 coulomb. Got it? Now I am going to discuss these particles. First, proton. The mass of these proton is 1.673 into 10 to the power minus 27 kg. In AMUs, it is 1.007 AMU, while the charge on it is plus 1.6 into 10 to the power minus 19 coulomb. Here I have to tell you that this value of charge is denoted by letter E, which is called as the elementary charge or fundamental charge or quantum of charge. What is elementary charge, or why it is called as the elementary charge? So here I have to discuss. It is called as elementary charge because it is the minimum possible value of the charge which can exist in free state. There is some values of charges which is less than E on some particles, but it is seen that those particles are not found in free state. These particles are found in clusters, in bundles, like quark particles. These quark particles are also of two types. One is up quark and other is down quark. Up quark is also of two types. The charge on these is plus or minus 2 by 3e. The charge on the down quark is plus or minus 1 by 3e. These are the values of the charges which is less than E. But it is seen that these quark particles are not found in free state. That is why I have told you that E is the elementary charge, which is the minimum possible value of the charge. Here, when I have discussed this quark particles, then I can tell you the composition of the proton. Actually, the composition of the proton is, it is 2 up quarks and 1 down quark. And that is why the charge on the proton, how can we calculate? 2 up quark means plus 2 by 3e, plus 2 by 3e, and 1 down quark, which is of negative value, 1 minus 1 by 3. So the total value of the charge is coming how much? Plus E. Proton is found in free state, and the minimum value of the charge on it is plus E. Now coming to neutron. Neutron, its mass is 1.675 into 10 to the power minus 27 kg, slightly heavier than the proton, and it is electrically neutral. I had already told you that it is having charge, but the amount of positive and the negative charge is equal. Here, when I have told you about the quark theory, the composition of the neutron is what? 1 up quark and 2 down quarks. 1 up quark of positive value plus 2 by 3e, and the 2 down quark of negative value minus 1 by 3e and minus 1 by 3e. That is why the net charge on the neutron is what? 0. And hence we say the neutron is what? Electrically neutral. Next particle is electron. Its mass is 9.1 into 10 to the power minus 31 kg, and in AMUs it is a 0.00055 AMU. And the charge on the electron, it is minus E. E means, as I have told you, it is 1.6 into 10 to the power minus 19 coulomb. And the next very important particle, alpha particle. You will use in so many numericals this alpha particle, so you must know what is the mass on it and what is the charge on it. Actually, alpha particle is the helium nucleus. We write it like 2He4. It contains 2 protons and 2 neutrons, and that is why we say the mass of this alpha particle is nearly 4 times of mass of proton. And the charge, as it consists of 2 protons and the charge on 1 proton is plus E, so the charge on the alpha particle is plus 2E. Got it? So in this manner we have discussed all these particles, their masses and the charges. Also I have defined what is the elementary charge. Now I will discuss the properties of charges. First property of the charge is a scalar quantity. Means whenever any 2 particles having different charges and we have to add the charges, then we can add them algebraically. Means if one charge is suppose plus 2e, another charge is q2 equals to minus 3e, and if I say what is the net charge, so net charge will be plus 2e and minus 3e, that will be minus e. Okay. Now next property is the charge is always associated with mass. In the previous video I have told that as a mass and the charge are the 2 inherent properties of the material bodies. So if there is any material body, it is having mass, it is having charge. One conceptual question comes, suppose if there is any electrically neutral body, and by any means if I say that this body has acquired positive charge, and I will ask what will be the effect on it? Mass. So I have to give you the answer that its mass will be reduced. Why? Because when it is electrically neutral body and you have to make it positively charged, definitely there will be some detachment of the electrons from it. And as electrons are detached, so along with the charge of the electrons, mass is also removed. And that is why the mass of the body will be reduced. So always the charge is associated with mass. Next property is the charge is conserved, or you can say the conservation of the charge. Means the charge neither be created nor can be destroyed. Any electrical neutral body, it can acquire charge only just because of transference of electrons. Suppose it is any body and you have given some electrons to it. So it is negatively charged. So whether the charge on the body is produced? No, it has acquired charge, negative charge, just because of transference of electrons. Or suppose there is a sodium ion and it has accepted one electron. So it is now sodium atom. So whether the charge is destroyed on the sodium atom? No. Only just because of the transference of electron, this charge is neutralized. So charge neither can be created nor can be destroyed. Next property is the charge is quantized. Or it is asked, what do you mean by quantization of the charge? So for it, I have to tell you that in physics there are 4 physical quantities which are quantized, which have their quantums, the minimum possible value. One is charge, other is mass, third is energy, fourth is angular momentum. And here the quantum of charge is E, the minimum possible value. Quantum of energy is h nu. Quantum of angular momentum is h upon 2 pi. And here I have to tell you that the quantum of mass is still not known. These quantities are quantized and these always exist in the integral multiples of E or h nu or respectively here h upon 2 pi. So quantization of charge means that whenever the charge on any body exists, that will be integral multiple of E. Means it may be plus minus E or plus minus 2E or plus minus 3E or plus minus NE. It cannot have the values like 3.2E, 5.2E, because I have told you that any body acquires charge just because of transference of electrons. And you can transfer the electrons in the integral values. Like you can transfer 2 electrons, 5 electrons, 10 electrons. So the charge on any body will be always integral value of the integral multiple of the elementary charge E. Here plus sign, we will use the plus sign if you have detached the electrons, means there is the deficiency of electrons in the body, and the minus sign will be used when the body has some excess of electrons. Got it? Now the last property of the charge is the charge is relativistically invariant. What's the meaning of it? Just like mass. For mass, we say by the Einstein's theory of relativity that whenever any body moves, it has the dynamic mass. And the dynamic mass is always more than the rest mass. But the inherent property, charge, it is invariant. Means if anybody is having charge and that is in motion, the value of the charge doesn't change. Got it? So all these are the properties of the charge. Okay?